Dear learner, welcome to our today's lesson. And in our today's lesson, we are starting a new subtopic altogether, and that is surface area. And in this lesson, we are going to deal with cuboids, surface area of cuboids. So before even we begin, we need to understand what we were doing last time, though it's not related to this. But there's one question that I have a concern with that looked like this. It consisted of a rectangle and two semicircles like that. You are given this as 110 meters, and this is dotted like this, and you are told this is 70 meters. Then you are required to get the area of the shaded region. Now, if you look at this question, you understand that this is a rectangle, and then we have two semicircles, two half circles. So for us to be able to get the area of this figure, number one, we have two features there. We have the rectangle. So area of the rectangle would be length times width. That is going to be, the length is 110 meters times the width 70 meters. This is going to give you 7,700 meters squared. Then from there, you're also going to calculate the area of the two semicircles. Now, there are two ways of doing this question, because this semicircle is the same as this one here. You can combine them to be a circle, a full circle. And our full circle in that case is going to have a radius of 70. If you can look this well, this one is the radius, because from the center of the circle to the circumference, so that becomes the radius. So if you combine the two, you will get something like this, where the radius is 70, and so area of a full circle is pi r squared. So this is going to be pi 22 over 7. The radius is going to be 70. Radius squared means the radius times the radius again, so 70 times 70. That is going to give you 22 times 10 times 70, which is 220 times 70. This is times 7, 14, 154 plus 2 zeros. So you get 15,400 meters squared. So total area will be equal to, this area, 15,400 meters squared, plus 7,700 meters squared. 0, 0, 1, this is 3, then 2. So our total area is going to be 23,100 meters squared. So that's how you can be able to do that, learner. So back to our lesson today. We want to discuss about surface area of cuboids. And before we do that, we need to understand what cuboids are. So a cuboid looks like what I am holding here. And only today we are interested in the surfaces, the faces. So a cuboid looks like this. It has one face, another one to make 2, this side 3, this side 4, then downward 5, and up 1, 6. In case it's open, we are going to remove one part, and so it's going to remain with how many faces? 1, 2, 3, 4, and the down one 5, because the sixth one is not there, because this is open. So we will understand that a cuboid has 6 faces, because that is what we are interested in today. So a cuboid has 6 faces, and these faces are what we are going to look at the area of. So if I can draw one here, it's very simple to draw one. Have it like that. That is one. So this one is measured. The number of faces I'm talking about is this one here on the wind side. You will have another one of this nature on the other side. Then this one on this length side. You have another one on this side. Those are 4 already. Then you have the top one and then the below one. Plus 2, you get 6. And so, if you want to get area of a cuboid, So we begin with a closed cuboid. When you want to get area of a closed cuboid, we'll draw just an example here. We'll draw an example here of a closed cuboid, which is going to have 20 centimeter by 10 centimeter by 5 centimeter. So you want to get the area of this a closed cuboid. This closed cuboid is going to have how many faces? So we are getting the area of the faces. The area of the faces. So we have face number 1. That face there. We have exactly another face like this on the other side. So they are going to be 2. So that's 2. And then the measurements are 20 by 5 times 20 by 5. So we get the area of that. The other one, this will give us 20 times 5 is going to be 50. 50 times 2, this is going to be 100 centimeters squared. We are done with this one and the other one on the other side. So we come to this side. This side measures 10 by the height, which is 5. So there are 2, this one and the other one, because it's a closed cuboid. So 2 times 10 times 5. 10 times 5. That is going to give you 50 times 2 again. This is going to be 100 centimeters squared. Then the below one. The below one is this one here. If you look at this one, it's a replica of what we have on the other side. So this measures 10 by 20. We are not considering the height in this case. We are only considering the length and the width. So that it's going to measure 2, and one is measuring 10 by 20. 10 by 20. That is going to be 200 times 2. 200 times 2, which is going to be 400 centimeters squared. So the total surface area is going to be 100 plus 100 plus 400. That is going to give us 600 centimeters squared. So that is the total surface area of that cuboid. Maybe we do another one so that we can understand. We'll do another one. Assuming you are given something like this, 45 centimeters, 20 centimeters, and 15 centimeters. I'm going to answer this question in terms of questions. I'm going to ask questions. A, how many sides, how many faces measures 45 centimeter by 15 centimeters? So we are going to answer in terms of a question. How many faces will measure 45 by 15? 45 by 15 is here. So how many faces are those? They are going to be 2. So we are going to say 2. So 2 faces are going to measure 45 by 15. B, how many faces measures 20 centimeter by 15 centimeters? 20, this is the face we are talking about. 20 by 15, this height. So they are going to be 1, and the other side we have another one. So they are going to be 2 faces. And then how many faces measures 20 by 45? 20 centimeter by 45 centimeter. You are going to understand that this face that measures 20 by 45 is this one here. So they are going to be this one and the below one. So they are going to be 2. And so we can ask ourselves, what is the total area of the faces? What will be the total area of the faces? For us to get the total area of the faces, we are going to get 45 times 15 times 2, because there are 2 faces. So 2 times 45 times 15, we get that area. Then we get 2 times 20 times 15, get that area. Then 2 times 20 times 45, we get that area. So after doing that, we will be able to get the area. So this is 45 times 2 is 90. So 150 times 9 is 0, 5, 1350. This is 1350 centimeters squared. Then you get 2 times 20 is 40. 40 times 15, that will give us 600. Sorry, this is 40. 40 times 15. 0. 2600. Actually, it's going to be 600 centimeters squared. Then the last one, 40 times 45. 0, 0, 16, 18, 1800. And so we are going to add that centimeters squared. After adding that, I'm sure you're going to get this is 2400 plus 1350. 0, 5, 7, 3. So 3750 centimeters squared will be the total area of that cuboid, which is closed. So that is how we're going to get that, Lana. Maybe to do one question for you again. Going to draw one here. Remember today we're first going to deal with area of an open, a closed one. So the last one, in terms of the closed one, can have something like this. This is going to be 30 meters by 15 meters by 5 meters. And you ask, find the total surface area of that closed cuboid. So, number one, we are going to identify the faces that measure 15 by 5. So there are 2, 15 times 5 to give us the area. Then 30 by 5. 30, there are 2 also. 30 times 5. And then 15 times 30, there are 2. The below one and the upper one. So 2 times 15 times 30. This is going to give us this 75. 75 times 2 is 150. These are meters squared. Plus this is 150 times 2 is 300 meters squared. This is 450 times 2 is 900 meters squared. Then we add all this. It's going to give us 1200 plus 150. So 1350 meters squared. It's going to be your area of this particular figure. So up to that, learner, we are able to calculate area of a closed cuboid. From there, we will move to area of an open cuboid. Area of an open cuboid. So, like I told you in the beginning, an open cuboid will have 5 faces because one will not be there. And so if you are drawing an open cuboid, learner, I encourage you to be doing this. Put an arrow just like that to show that one is open, or you put some dotted line to ensure that you can be able to see inside. If you can be able to see inside, then it's open. So we are going to calculate surface area of something like this. If you count the faces, we have 1, 2, 3, 4, and then down 1, 5. So that we want to remember that the below face is only 1. The upper one is not there. So if this is 20 centimeter, this is 10 centimeter, and this is 4 centimeter. Can we be able to get the area of that open cuboid? So this is open cuboid, meaning that we are going to have 5 faces. So let's calculate, see how many faces measure 10 by 4. So this is 4. So there are 2. 10 times 4. We get the area of that. Then how many faces measure 20 by 4? There are also 2. 20 times 4. And then how many faces measure 10 by 20? 10 by 20 is the upper one, which is not there, so the below one. So it's going to be 1 times 20 times 10. Then we get the total area. This is 10 times 4, which is 40 times 2, which is going to be 8 centimeters squared. Then 20 times 4 again, this is going to be 80 centimeters squared. Then 20 times 10 times 1, this is going to be 200. That is going to give us 0, 6, 3. 360 centimeters squared. So that's how we're going to get planar. So we are going to exclude 1, the longer side, which is lying at the base. So it's going to remain 1. It's going to remain 1. So let's do a final question. Find the surface area of this kind of a figure. There is a figure here. And the figure looks like this. That figure measures 7 centimeter by 12 centimeter, and then by 6 centimeter. So as you can be able to see that this one is open, this one is not there. So it's an open figure. So which one is not there? It's open. I say you can draw like that, so that you can be able to know. So this face, which is measured 7 by 12, is only one. The other one is not there. So we are going to begin from there. So one face measures 7 times 12, and it's only one. That is going to give us 84 centimeters squared. Then next we are going to have this face here. The longer one is measuring 7 by the height, which is 6. So 2, there are 2. There is this one. If you can be able to see well, there is another one on the other side. So there are 2 measuring 7 by 6. That's going to give us 42 times 2, which is 4 centimeters squared. Then there is another one, this bigger face, this one. This face measures 12 by 6, and there are 2. 12 by 6. That is going to give you 72 times 2, which is 144 centimeters squared. Get the total surface area. This is 168. 168 plus 144 is going to give you 213. So 312 centimeters squared. 312 centimeters squared. So that's how learner you can be able to get these questions clear. So number one, you are going to identify the number of faces in the cuboid that you are given. After doing that, you can be able to calculate the area. You must know which one is there and which one is not there. After knowing that, you'll be able to get the area. I think up to that end, we can be able to do a question. But before that, I want to do one question. It's a word question that says, I don't know whether to write the question. Let me write the question because it's very, very important. It concerns something that comes in an exam. So I'm going to write very fast. Learner copy very fast what I'm going to write. So a question goes, Mwachia wants to make a rectangular water tank. Question. Mwachia wants to make a rectangular water tank. Whose top will be open. Whose top will be open. Full stop. Question continues. He wants to do this using metal sheets. He wants to do this using metal sheets. The tank is to measure 1.5 meters tank is to measure 1.5 meters long, 1 meter wide, and 0.5 meters high. 0.5 meters high. Then the question continues. A. How many square meters of the metal sheets will be needed? How many square meters of metal sheet will be needed? Let's begin from there, Lana. If you look at this question, they are talking about a rectangular open tank. So the most important thing for you is to draw this diagram. A rectangular one. We are told it's open, so you put your arrow like this. And this tank measures 1.5 meters long by 1 meter wide, that is the width, and then 0.5 meters high, that is the height. So the question is, how many square meters of metal sheets will be required? In other words, this person is telling you to find the surface area of this tank. So we will begin by knowing how many sides measure 1 meter by 0.5. There are two, this one and the other one. So 2 measure 1 meter times 0.5 meter. You get the area of that. The almond measure 1.5 by 0.5. There are also 2. There's another one on the other side. So 2 measure 1.5 meters by 0.5 meters. You get the area of that. Then lastly, you get to know how many measure 1 meter by 1.5. It's 1 because the other one is not there. So 1 measure 1 meter times 1.5 meters. So you get that area. This is 2 times 1 times 0.5. 0.5 times 2 is 10. So 1 decimal place, you get 2. We're going to get 1. So this is going to be 1 meter. 1 meter squared. This is going to be 2 times 1.5 times 0.5. Here you're going to get, this is 30. 30 times 5. That times 5 is 150. Then how many decimal points? 1, 2. 1, 2. So 1.5 meters squared. And the last one is also going to be 1 times 1 meter times 1.5. That is going to give you also 1.5 meters squared. Then we add that. When you add that, you get 4 meters. This is going to be 4 meters squared. So 4 meters squared of the metal sheet is required. We go to question number 2. Question number 2 says, so we have answered A. B says, how many square tiles, what will be the cost of the metal sheets? What will be the cost? What will be the cost of metal sheets? Metal sheets. If 1 square meter costs 509 shillings. Costs 509 shillings. 1 square meter costs this. So how much will be the cost of buying those metal sheets? So it's very simple. You say if 1 square meter is written like that, is equivalent to 509 shillings. What about how many did we get there? We got 4 meters squared. Is what amount? So you cross multiply. This is going to multiply with that. So 4 meters squared times 509 shillings over 1 meter squared. Meter square and meter square will cancel. You remain with 4, and then the units here will remain shillings. So 4 times 590. If you multiply this by 4, you get 0, 6 carry 3, 20, 23. So you're going to get 2,360 shillings. 2,360 shillings will be the cost of the 4 square meters of iron sheet that is required to make this tank. So I was giving that question because most time in exam they bring such questions. So how are you going to handle such a question and get it right? So learner, in our practice questions, I want you to attempt the following questions. Actually, exercise 80, primary maths, exercise 80, that is on page 129, 129 through page 101. 101. That will be your practice exercise. Kindly do it and do it properly. Where the cuboid is open, show that it's open, and you'll get the answers correct. So until next time, now next subtopic is going to be the surface area of cylinders. Let's meet in our next lesson and we enjoy this lesson. So until next time, I wish you all the best. Stay at home, stay safe and sanitize. Thank you.